Actually, maybe you'll say, hey, sine and cosine, it's okay. Because remember, we're trying to understand, look into the future, that the derivative of u is supposed to cancel with the rest of the problem. So the derivative of sine is cosine. Maybe that's the cancellation connection. How about the derivative of cosine? Well, yeah, it's negative sine, right? Ooh. So this is a problem where we kind of realize that there's some connection between these two. Okay, now, are there some problems where sometimes you learn just by choosing it the wrong way? Yes, there are some. I think I might do one of those. This problem, it's a little more clear that because of this square, that would then say that, okay, this has to be the inside function. Because you've seen this now more than once, that the square is the outside function. So thinking inside-outside is a good way to approach a substitution problem. But I'm telling you, when you really figure this out, you're going to say, this is u, 1 plus sine of x over 3. Okay, when you really figure this out, you're going to say that that is equal to u because du, which we kind of mentioned loosely, the derivative of sine is cosine, okay, is going to cancel with this over here. Now, we got to be careful. It's not just as easy as just saying, hey, they're going to cancel. We got to be careful when we do the derivative. Like, we got to remember how to do the derivative of, well, the derivative of 1 is 0, but the derivative of sine is cosine. Do you feel like you need to leave the inside alone? You should feel like you're using the chain rule. So I did the derivative of the outside, that's the derivative of sine is cosine, but I left the inside alone, which really is to get us to do the derivative, to do the rest of the chain rule, to do the derivative of the inside. Careful, I know that this right here, the derivative of x over 3, that can stick it to people. How about thinking of x over 3 the same as 1/3 x? Okay, x over 3 is the same as 1/3 x. That should make it a lot easier to do the inside derivative. The derivative of the inside is just going to be 1/3. Okay, I have to admit I forgot, but it's important. Yeah, you need the dx. What is that dx? It's kind of like the du dx. It's that derivative fraction, but it's just split up. So we put dx on the other side. Some of you, it would benefit you to think about the substitution. Some of you, maybe you just need to listen to the teacher again. You're only going to learn this, though, when you actually try to do it. Can you write the new integral in substituted form? I'm showing this modified substitution here. It's kind of like a modified cancellation, actually. If you're wondering what I'm trying to show, these two boxes are equal. That's kind of what I showed in that other problem, but sometimes it's more clear here. Again, I'm just wondering where you're at. Some people say thank you, but no thank you. I decided to only multiply 3 to the other side. I decided to leave it as cosine of x over 3 dx because that's exactly the same as this end of this equation. So that means that I can substitute a 3 du for that entire box. Some of you would have divided by cosine, and those of my students that divided by cosine, then you would have canceled out the cosine. You would have canceled it out. But we're left with a 3 and basically a u squared. Okay, 3u squared. I don't know if you need to rewrite it, but is there anything you want to ask about? We're not done, but do you have any question on substitution? Okay, remember, the whole reason we're doing this is so I can get to something I can actually integrate using a basic rule. That's always what happens here. You turn it into something from yesterday's quiz. So add to this exponent, divide by the new exponent. It was even meant to do some extra canceling. You basically just end up with u to the third power. U to the third power is the same as 1 plus sine x over 3 to the third power. I hope you're not sort of hesitant to ask, because I can only help you if I know what you're wondering. Is there anything you want to ask? Try to keep in perspective this thing right here. This thing right here, we're calling it capital F of x, but if I do its derivative, that is, if I go back, I should end up with this problem. And so if I do the derivative, I'm going from the first half of the year, I'm going to do the derivative of the outside, finish the outside, and then don't forget to do the chain rule. That's the derivative of the inside. The derivative of 1 is 0. Oh, I kind of already did it over there, but I'm going to end up getting exactly where I started, noting particularly that the 3's cancel out. And again, that takes me back to the original integral. Most people don't do this, but I'll just point it out. You could type this into the slope field program. I have no idea what it's going to look like. It's probably crazy, but this is like the derivative, and then I could graph this on top of it. It is a nice way to check your work. Some people will do it in a crunch. Again, type that in the slope field, graph this on top of it. Don't worry about the C. All it's going to do is move the graph up and down, but you'll see that it goes with the flow, and you'll see that you're right. Yeah, just stick it over here. Okay, let me give you one to just straight up try. We're not going to make it bonus or just kind of straight up try as much as you would like. If nothing else, it'll give you a little idea that what you're understanding. Maybe it'll give you an idea of what you still need some help on. Maybe you would like to have a different problem, but I just know that if you actually sit down and start thinking about this, you'll be able to figure some things out. So instead of just listening to me, can you integrate tangent squared of 3x times secant squared of 3x? Okay, now I'm not just going to do the problem, but let's keep learning. It is not uncommon to do that. I might even say I almost expect you maybe at some point to have thought that. It's not right, because when you start to look into the future, you realize that the derivative, it's not like robust enough. Like there's nothing wrong with the derivative just being a number. We had a problem like that in the beginning of the lesson. But for this problem, you got to look at it and say, there's a lot of stuff up here. Something probably needs to cancel. The reason something probably needs to cancel is because when you have like multiple functions, you're trying to turn them into one u function. Nothing's going to cancel if all I've got is a 3. In other words, that's not going to cancel tangents and secants or whatever function needs to disappear. So we have to do better than that. Do you see a derivative cancellation connection? Like, what if I said to you, do you see a function up here, basically either tangent or secant, because that's kind of like the only thing that's left. Do you see a function up here like tangent or secant whose derivative is kind of like connected to the other one? What's the derivative of the tangent of 3x? Oh, good. You're getting into the details, but the derivative of tangent is secant squared. Okay, you got to figure out how that applies to this problem. If you're like, okay, so what does that mean? It means something with u. If you understand that the derivative of tangent is secant squared, then you understand, or at least I want you to understand, u. I'm going to do something to also encourage you on to greatness here. Okay, I did something which is pretty nice, but I still want you to think about what Colton said. The derivative of tangent is secant squared. It's a good sign that you guys kind of took the hint that you understand that u is tangent of 3x. I actually have to do the problem to kind of think about the final answer. Okay, now be careful. I certainly would never mention a name, but some of you just got to make sure your derivative is right. Be careful. Derivative of tangent is secant squared with the inside left alone. That means it's still 3x times the derivative of the inside. That's the chain rule, times 3. Okay, so 3 secant squared of 3x, dx. I'm really impressed, you guys. You're gonna get this. You have to work at it. Some of you, you're missing a 1/3. Those of you that have the 1/3, you know what I'm talking about. But like your answer is all good. It's just like off by 1/3. By the way, the final answer doesn't even have 1/3 in it. The final answer actually has a ninth in it. I decided to go back to my roots, which was to kind of like solve for dx. Okay, if you just straight up always solve it for dx, it will work. It might be extra work, but you'll be able to get your the rest of the problem to cancel. But you got to see that there's a 1/3 right here. Okay, that 3, it's really not a 3, it's really a 1/3. So now we're staring at the anti of 1/3 u squared. Remember, we didn't actually do the antiderivative yet. That means I never really changed the essence of this problem. The essence of this problem is u squared. But now I'm going to change it. I'm going to change it to be u cubed divided by 3. In other words, 1/9 of our inside cubed. So we can just swap the inside back in there, that tangent of 3x. I would accept that answer. I have to admit that it would, if you got that far, you might as well write it as tangent cubed, like we should put an exponent on a trig function. So 1/9 tangent cubed of 3x. And kind of remember maybe where you started. I saw a lot of you starting with u equal 3x. Remember what I said about that? It's not enough. The derivative is not enough. So we kind of look again at a better u.